According to ASHRAE Standard 62.1-2019, Section 6.54.4, the load of a 5 HP water pump in an emergency fire alarm system can sometimes be discounted from the overall load calculation for a building. This is generally permitted because emergency fire alarm systems are designed and required to operate independently of the normal electrical power supply. These systems are crucial for life safety and must function reliably even when the main power source is disrupted. To ensure this reliability, emergency fire alarm systems are typically equipped with a dedicated backup power source. This backup power source may take the form of a generator, which automatically starts and provides electricity when the normal power fails, or a battery system which can supply power for a limited duration. Because these systems are powered separately during emergencies, their load is not considered part of the normal operating load of the building. The rationale behind this is that the main load calculation is intended to determine the normal electrical demand of the building, which is used for sizing the electrical service, distribution equipment, and backup systems that support regular operations. Including the emergency fire alarm system's load in this calculation would lead to an overestimation of the normal electrical demand, resulting in oversized and potentially inefficient electrical infrastructure. However, there is an important exception to this rule. If the emergency fire alarm system is connected to the normal electrical power supply as a backup, its load must be included in the load calculation. This scenario typically occurs when the emergency fire alarm system does not have a dedicated backup power source, such as a generator or battery, and relies on the normal electrical supply as its primary or secondary power source. In such cases, the emergency fire alarm system will draw power from the normal electrical supply during both normal operations and emergencies. Therefore, its load must be accounted for to accurately determine the building's total electrical demand. To summarize, you can generally discount the load of the 5 HP water pump in the emergency fire alarm system from the load calculation if the system has a dedicated backup power source and operates independently of the normal electrical supply. However, if the emergency fire alarm system relies on the normal electrical supply as a backup, you must include its load in the load calculation. The purpose of a load calculation is to determine the appropriate size of the electrical service for a building. It's a critical step in electrical design that ensures the building's electrical system can safely and reliably meet its anticipated demand. A load calculation involves summing up all the expected electrical loads within the building, including lighting receptacles, HVAC systems, and any specialized equipment. Understanding how to properly account for different types of loads, such as emergency systems, is essential for accurate load calculations and safe electrical system design. Firstly, you need to identify all the loads within the building. This includes lighting, receptacles, HVAC equipment, appliances, and any other electrical devices. Each load should be carefully assessed to determine its power consumption in watts or kilowatts. Secondly, once you have identified all the loads, you need to determine their demand factors. Demand factors are multipliers that account for the fact that not all loads will be operating at their maximum capacity simultaneously. The demand factor for a particular load depends on its type and usage pattern. For example, lighting loads typically have a lower demand factor than motor loads because lighting is often used intermittently. Thirdly, after determining the demand factors for each load, you can calculate the connected load. The connected load is the sum of all the individual loads multiplied by their respective demand factors. This represents the total electrical demand of the building under normal operating conditions. Fourthly, in addition to the connected load, you also need to consider any diversity factors. Diversity factors are multipliers that account for the fact that not all loads will be operating at their maximum capacity at the same time. The diversity factor for a building depends on its type and occupancy. For example, a residential building typically has a higher diversity factor than a commercial building because residential loads are more likely to be spread out over time. Fifthly, once you have calculated the connected load and applied any diversity factors, you can determine the service size. The service size is the minimum capacity of the electrical service required to meet the building's electrical demand. The service size is typically expressed in amps or kilovolt amps. It's important to consult the local electrical code and utility regulations when determining the service size. Understanding load calculations is important in that they are essential for ensuring the safety and reliability of a building's electrical system. An accurate load calculation can prevent overloading of circuits, which can lead to overheating, fires, and equipment damage. In addition, an accurate load calculation can help optimize the size of the electrical service, reducing energy consumption and costs. When conducting a load calculation, it's important to follow a systematic approach and consider all relevant factors. This includes identifying all the loads, determining the demand factors, applying any diversity factors, and consulting the local electrical code and utility regulations. A thorough and accurate load calculation will help ensure the safe and efficient operation of the building's electrical system. Different types of loads need different calculations. For example, lighting loads. Lighting loads are a significant component of the overall electrical demand in most buildings. To calculate lighting loads accurately, it's important to consider the type of lighting fixtures used, their wattage, and the area they illuminate. For incandescent lighting, the power consumption is simply the wattage of the bulb. However, for fluorescent and LED lighting, the power consumption is typically lower due to their higher energy efficiency. To determine the actual power consumption of fluorescent and LED fixtures, it's necessary to refer to the manufacturer's specifications. Receptacle loads are another important consideration in load calculations. Receptacles are used to power a wide variety of electrical devices, from small appliances to heavy-duty equipment. To calculate receptacle loads accurately, it's important to consider the type of receptacles used, their amperage rating, and the number of receptacles in each area. For general-purpose receptacles, the load is typically calculated based on a minimum of 180 volt amps per receptacle. However, for dedicated receptacles that serve specific equipment, the load should be based on the actual power consumption of the equipment. HVAC loads account for a significant portion of the electrical demand in many buildings, especially in climates with extreme temperatures. To calculate HVAC loads accurately, it's important to consider the type of HVAC system used, its cooling and heating capacity, and its energy efficiency. For central air conditioning systems, the load is typically calculated based on the system's cooling capacity in tons. 1 ton of cooling capacity is equivalent to 12,000 British thermal units per hour. For electric heating systems, the load is typically calculated based on the system's heating capacity in kilowatts. Motor loads are common in many buildings, especially in industrial and commercial settings. Motors are used to power a wide variety of equipment, from pumps and fans to compressors and machine tools. To calculate motor loads accurately, it's important to consider the motor's horsepower rating, voltage, and full load amperage. The full load amperage is the amount of current the motor draws when operating at its rated horsepower and voltage. This information can be found on the motor's nameplate. In addition to the factors discussed above, there are several other considerations that can affect the accuracy of load calculations. These include the building's occupancy, the type of activities conducted in the building, and the local climate. For example, a hospital will typically have a higher electrical demand than an office building due to the specialized equipment used in healthcare facilities. Similarly, a building located in a hot climate will typically have a higher cooling load than a building located in a temperate climate. One must consult with the local electrical code and utility regulations. Electrical codes and utility regulations often specify minimum requirements for load calculations. These requirements may include minimum lighting levels, receptacle spacing, and HVAC system efficiency. It's important to be familiar with the applicable codes and regulations to ensure that your load calculations are compliant. Load calculations are not a one-time task. They should be reviewed and updated periodically to reflect changes in the building's occupancy, equipment, and usage patterns. For example, if a new tenant moves into a building or if new equipment is installed, the load calculation should be updated to account for the changes. It is important to maintain accurate records of all load calculations, including the assumptions and methodologies used. This documentation will be helpful for future reference and for troubleshooting any electrical problems. In addition to the specific information provided in the ASHRAE standard, there are other resources available that can help you with load calculations. These include electrical engineering textbooks, online calculators, and software programs. Many electrical engineering textbooks provide detailed guidance on load calculation methods and examples. Online calculators can automate many of the calculations involved in load calculations. Software programs can help you manage and analyze large amounts of data for load calculations. One should consider using energy-efficient equipment. Energy-efficient equipment can significantly reduce the electrical demand of a building. When selecting equipment, look for products with high energy efficiency ratings. This will help you minimize the building's energy consumption and costs. It is also important to consider the long-term costs of equipment, including maintenance and replacement costs. Energy-efficient equipment may have a higher initial cost, but it can often save money in the long run due to lower energy consumption and maintenance costs. It is vital to also consider the potential for future expansion. When designing an electrical system, it's important to consider the potential for future expansion. The electrical service should be sized to accommodate future loads, such as new equipment or increased occupancy. It's also important to plan for future technology upgrades. New technologies, such as electric vehicle charging stations, may require additional electrical capacity. By planning for future expansion, you can avoid costly upgrades and disruptions in the future. Load calculations are a critical aspect of electrical design and should be performed carefully and accurately. By following the guidelines and best practices outlined above, you can ensure that the electrical system is safe, reliable, and efficient. Remember to consult with qualified electrical engineers and contractors for assistance with load calculations and electrical system design. These professionals have the expertise and experience to ensure that the electrical system meets the building's needs and complies with all applicable codes and regulations. The 5 HP fire pump in the emergency fire alarm system could draw approximately 28 amps at 208 volts, 14 amps at 480 volts, or 12 amps at 575 volts, depending on the voltage of the system. These are approximate values, and the actual current draw may vary depending on the specific motor and pump characteristics. These values should be considered when deciding whether or not to include it in the total load. The National Electrical Code, or NEC, provides guidelines for calculating electrical loads in buildings. Article 220 covers branch circuit, feeder, and service calculations. These guidelines help ensure the electrical system is adequately sized to handle the expected load. NEC Table 220.12 provides general lighting loads by occupancy. NEC Article 215 covers feeder calculations. Feeder conductors must have an ampacity not less than the calculated load. NEC Table 310.16 provides the allowable ampacities of insulated conductors. The ampacity depends on the conductor material, size, and insulation type. NEC Article 230 covers service calculations. The service conductors must have an ampacity not less than the calculated load. Emergency systems are covered in NEC Article 700. These systems provide power to essential loads during a power outage. Emergency systems must have a separate source of power, such as a generator or battery. Fire pumps are covered in NEC Article 695. Fire pumps are used to provide water to fire suppression systems. Fire pumps must have a reliable source of power and must be protected from overload and short circuits. When performing a load calculation, it's important to consider the voltage drop in the conductors. Voltage drop is the reduction in voltage along a conductor due to its resistance. Excessive voltage drop can cause equipment to malfunction or fail. The NEC recommends limiting voltage drop to 3% for branch circuits and 5% for feeders. To minimize voltage drop, use conductors with a larger cross-sectional area. In addition to the NEC, there are other standards and guidelines that may be relevant to load calculations. These include standards from organizations such as the Institute of Electrical and Electronics Engineers, or IEE, and the National Fire Protection Association, or NFPA. It is important to be familiar with all applicable standards and guidelines to ensure that your load calculations are accurate and compliant. One should utilize load calculation software. There are many software programs available that can help you perform load calculations quickly and accurately. These programs can automate many of the calculations involved and can help you identify potential problems. However, it's important to remember that load calculation software is only a tool. You should always verify the results of the software and use your own judgment to ensure that the load calculations are accurate and reasonable. A systematic approach is the best way to handle load calculations.